Hello students, let's welcome to our YouTube channel Physics for UG. So in this video, we shall discuss about coherent sources. So what are coherent sources? And remember, the coherent sources are very much important while studying the interference pattern. Whether it is interference due to single slit, double slit, or whatever, and coherent sources are very important. Without coherent sources, interference cannot be obtained. So what are coherent sources? When two light sources produce waves having constant phase difference with time, whether they have constant phase difference or zero phase difference, whatever be the cause. Either two waves have zero phase difference or two waves have constant phase difference. Then we say the two waves are coherent sources. Okay. Next, that coherence is of two types. First one is temporal coherence and another is spatial coherence. Let's discuss one by one. What is temporal coherence? The temporal coherence is known as also longitudinal coherence. Temporal coherence is a measure of a relation between the phases of a wave at different points along the direction of propagation of the wave. So temporal means it is related to time. So time related coherence. So temporal coherence is a measure of relation between the phases of a wave at different points along the direction of propagation of wave. Okay, now in the figure consider there are 2 points. This point is A and another point there is B. Now look at the consider a light wave traveling along the x-axis as shown in the figure. This is the figure. Okay, let A and B are 2 points on the wave which lie on the x-axis. Let phi A and phi B are the phases waves at points A and B at any time. So at point A the phase is phi A and at point B the phase is phi B. So then the phase difference will be, what is the phase difference? Delta phi equal to phi A minus phi B. Suppose at this point the phase is something, suppose this is 0, this point is pi, this point is 2 pi, this point is 3 pi, this point is 4 pi, this point is 5 pi. So take an example, this is the phases of the wave at different points. So at point A, what is the phase? That is pi. And what is the phase at point B? That is 4 pi. Then what is the difference? Difference is 3 pi. Difference is 3 pi. Or that take minus 3 pi, that modulus is plus 3 pi. So if delta phi is independent of time, that means delta phi remains constant and the wave is said to have temporal coherence if phi and phi b always remains constant. Suppose the wave travels along the wave travels on the x-axis. Suppose after some time that point A and B also have the phase difference 3 pi, and after suppose 5 minutes the phase difference is 3 pi, and after 10 minutes the phase difference is 3 pi, after 1 hour the phase difference is 3 pi. Then what is the result? Del phi. Del phi is the phase difference and this part is independent of time. Whatever be the time, the del phi is remains constant. Then the wave is said to have temporal coherence. So what are the lines? Thus, if the phase difference of the wave crossing 2 points lying along the direction of propagation of wave is independent of time, that is phase difference is constant. If the phase difference between 2 points along the same line like as A to B and 2 points A and B, the phase difference remain constant with the time, and this is called temporal coherence, and the wave is said to have temporal coherence. Clear? Now let's move to the next part, that is spatial coherence. This is also another important part, that is spatial coherence. What is spatial? Spatial means related to space or related to some place, that is spatial coherence. Temporal means time coherence and spatial means space coherence. So this is also another name, that is transverse or lateral coherence, that is transverse coherence or lateral coherence. So what is spatial coherence? Spatial coherence is also known as transverse coherence. or lateral coherence. A beam of light is said to possess spatial coherence if the phase difference of the waves crossing two points on a plane perpendicular to the direction of propagation of the beam is time independent. Okay, look at the figure. Suppose there are two waves traveling along one along x-axis and another along x-axis. Suppose two waves are traveling. Let's draw a plane that is A, B, C, D, and that plane is perpendicular to the wave propagation. Okay, suppose there are 2 points P and Q, 2 points P and Q. So if the phase difference between P and Q remains constant, that is called spatial coherence. How? Now, if there is no phase difference between 2 points or phase difference between them is 0, the two waves are in spatial coherence. For this region, spatial coherence is also called transverse coherence. Transverse means if the wave, if we take the coherence along the direction of propagation of wave, that is called longitudinal, because that is along the length, that is longitudinal coherence. And if we take the coherence with perpendicular to the propagation, that is called transverse coherence. Transverse means perpendicular to the length. So consider a beam of light traveling along x-axis. Let ABCD is a plane perpendicular to the beam. This is the beam along x-axis and ABCD is the plane perpendicular to the x-axis. Let P and Q are 2 points on this plane within the beam of light as shown in the figure. This is the figure. Now let the phases of waves crossing points P and Q at any instant of time be phi P and phi Q respectively. Let at point P the phase is phi P, and at point Q the phase is phi Q. So the difference between these two, then delta phi equal to phi of P minus phi of Q. So delta phi is independent of time, it is always constant. Then the beam of light is said to possess spatial coherence. Okay, if delta phi is independent of time, that means delta phi remains constant with time. Delta phi is the phase difference between these 2 points. If it remains constant, then we can say that they have spatial coherence. So basically the basic difference between spatial and temporal coherence is that in temporal coherence the wave propagates along single direction, and if we compare the phase difference between 2 points along the same direction, that is called temporal coherence. That means in temporal coherence the phase difference remains constant along the same direction between 2 points. Okay, but in spatial coherence what happens? There is a plane perpendicular to the direction of propagation, and on that plane there are 2 points on that plane from the two waves traveling along the same direction. If the along 2 points the wave, the phase difference remains constant, that is called spatial coherence. Thank you. If you like this video, then subscribe the channel, like the video and share the video. Thank you.